I work with APNIC. I have a confession to make. After being in this business for way too many years, I've never been to a NANOG before. So thank you for having me, and certainly I'll try and repay your hospitality by at least giving you a couple of presentations. The first one today is largely technical, and I want to talk about something near and dear to all of our hearts, which is autonomous system numbers. Tomorrow I think I'm a little bit more fanciful in trying to figure out what's going to happen to this industry over the coming years. But this morning is more nitty-gritty, and it really is a topic that I sort of wandered into by accident, looking at autonomous system numbers and how quickly we're using them. The original design of BGP, and that dates back to the late 80s, early 90s, made the wild-eyed, fantastical assumption that there'd never be more than 65,536 separate autonomous routing domains in this world. Considering that at the time there were a little under 200 monopoly telcos operating, this did seem a remarkably fanciful number. Oddly enough, we're chewing through it pretty quickly. This is the total map of all of the AS numbers. The blue is what I see in the routing table. Each column is 256 numbers. The first column is 0 to 256, the next 257 to 512, and so on. So the blue is what I see in the routing system from a couple of days ago. The red is what the RIRs gave out over time, but I can't see it. Notice that the lower the number, the more likely it is to be red. So after you use AS numbers for a while, you get tired of them, you folk, and you throw them away to the great AS graveyard in the sky. The green is what's left that we could still allocate from in our current pools, and the yellow over there on the right is what IANA has left. So let's put some numbers on that. Out of the 65,536, 1,024 are private use, 0 is reserved, and 23,456 is reserved, which you'll find out more about later. That leaves you with 64,510 AS numbers, and we've chewed through a little under 40,000, leaving us a little under 25,000. So this morning I actually want to go through three things very quickly. When are we going to run out of this remaining pool? What are we going to do then? And how are we going to do it? How does it impact you and I in trying to run the routing system? So the first, when? This presentation and the one that follows tries to make some guesses as to how fast we're chewing through them. And it uses public data sources. In this case, what I use is periodic snapshots of the BGP routing table, predominantly from the RouteViews project. So this dates back to around November 1997. Thank you, RouteViews. I also go through the RIR assignment data and try and collect a time series from that. I also have combed through the IANA data, and from that I've tried to figure out the AS count of unadvertised numbers. And then I'm trying to push forward and try and make some forward extrapolations here. And rather than taking the whole history, I've just used the previous 1,000 days, and we'll see why. So firstly, what am I assuming? The first thing I'm assuming is that for whatever reason, you happen to like your old AS numbers. You've grown fond of them, you've attached to them, and you're never going to give them back. So there is no recovery of unused AS numbers in this model. In actual fact, I'm really not sure why you'd bother. I actually don't think there's a real benefit in so doing. So in actual fact, my assumption assumes that whatever you have, you keep. Secondly, and this is a little bit more contentious, and when I thought about it, it wasn't really obvious, but I don't think AS numbers will saturate. I actually think there's going to be constant and continued demand. Why? If I think about it, what I see is actually the use of AS numbers in a number of contexts, but increasingly we're doing finer grained traffic engineering further and further down the hierarchy of connectivity. And in actual fact, right now, in the way it works in the routing system, multi-homing works by effectively announcing more specifics. And the easiest way of doing that is with your own autonomous system number. So that what I'm seeing is more and more finer grained use of AS numbers. And if you happen to look into this and actually plot the amount of address space per announced AS, you see that it's going down, which kind of corroborates the fact that realistically we are chewing through them at a pretty high rate, and by all accounts look to continue to do so. So it's just business and it'll keep on going. The other thing I'm assuming, and I think in this case it's right, but in V4 it's horrendously wrong. But for AS numbers there's no rush, because the transition out of this space is relatively painless. And if you already hold an AS number and already have deployed BGP, you don't have to do anything. So there's no real reason to rush on the remaining numbers. That's not the same as V4. So in this model, I'm assuming that there's no scarcity-induced rush. We'll just plough through. So the first piece of data. This is the advertised AS count since '97. The big factor there is the internet boom. You see it in the middle of the graph, that steeply rising exponential trend. And according to the way business worked, the crash happened in March, about March the 10th, 2001. All of a sudden, AS growth in the routing table stopped and started a new line. What exactly that line is hard to tell at this level. You could do a linear plot, you could do an exponential plot of the last 1,000 days. And it's not clear which of those models is better at this level of granularity, but the answers are pretty different. At an exponential growth model, you're looking much, much closer to 2014 than not. At a linear growth model, you're going, 2024, which, is probably not in my lifetime, or at least very close to my retirement. Which is better? One of the ways of looking at doing trend fitting is to actually figure out what your mean error rate is. So what I've plotted is the mean error of each of those daily samples for both linear and exponential. The red is linear, the green is exponential. So that what I see at that level of detail is in fact that the number of ASs we're using is growing. So there is a small but quite discernible exponential growth trend happening. So now I can be a little bit more definitive as to what's going on. Let's construct the model now. Firstly, you kill off old AS numbers and keep them. Around 5% of the existing alive AS numbers are going to die this year, and whatever you're going to do with them, maybe you eBay them, I don't know. 5% of them are going to disappear and become unadvertised. They're not going to come back, they're not going to be reclaimed, they're just going to disappear from the routing table. Maybe you use them in MPLS VPNs as the VPN ID, the graveyard of AS numbers. The other thing I found is that recent assignments take around 4 months to actually appear in the routing table. So once you actually get an AS number, there's a certain amount of work you need to do before you actually announce it. So that's taken into account as well. So what I'm trying to do, at least at this stage, is to figure out when we have a problem. At what point we'll need to actually have something else on the ground and running. So, a number of factors here. I'm using an exponential growth trend for the advertised numbers. What I haven't shown, but is in some of the references, is to how I then plot the growth of unadvertised numbers. And the way I've done that is to use a best fit of saying that the unadvertised numbers are growing at a ratio according to the advertised. And what I'm finding is that the unadvertised pool is growing, but at a slower rate. So then I look at the RIRs themselves, the 5 points where AS numbers are allocated, and look at their relative consumption rates and model the way the RIRs work. And I'm trying to figure out the date at which any RIR can't say yes, the date at which their particular number pool is exhausted. So the first RIR that runs out is the date that I'm looking for. Here's the big model. I won't go through the details of how I got there, but it's divided into half. The left half is what we've seen, the right half is where we're going. The red line from the left to the right going down is IANA. That pool of IANA numbers, which is currently 25,000 left, is exhausting, and the red line declines as the exhaustion rates continue. The green line going up is the RIR allocation activity, and you can see there the exponential growth trend. That line is curved slightly upwards. Below it, the blue line is what we're advertising in the BGP routing table. And again, the best fit indicates a slightly rising growth trend. The unadvertised numbers are going to go in the next line down, and down the bottom, all that fuzzy stuff, is the way the RIRs themselves operate. What does it mean? As far as I can tell, in looking at those numbers, the best fit is that we'll exhaust the last available AS number on the 14th of October 2010. I haven't quite figured out what time of the day yet, but if you give me a bit of time, probably we can get there. The assumptions behind that: when you don't need your AS number, you're going to keep it. There's no reclamation. The RIR's assignment policies will continue largely as they are now, no real change. A steadily increasing consumption trend, and no last chance rush is going to happen. So we're just going to steadily move towards that exhaustion point. What are we going to do about it? There is a proposal kicking around inside the IETF and has been for quite some years. I think about 5 years from memory. We're up to version 11 of the draft, and it's a relatively simple change. You take all the places where you see 2-byte AS numbers and change it to be 4 in almost every case. The only case where you don't change it is in the open field, where I first initiate a conversation. That remains a 2-byte field because I don't know who I'm talking to. But in all other cases, you simply change it to be 4-byte fields. That gives us 4 billion AS numbers. The number is reminiscent, it's the 32-bit space all over again. And if we ever run out of those, God knows what we'll be doing in the industry, and God knows how big your routers are going to be. Because with that many AS numbers in play, life will be hell. Carry all the AS numbers using 4-byte fields, and the only real places you see it in the BGP protocol spec is actually in the AS path and in the aggregator fields. So these are fields in the update messages. So those fields are effectively expanded to carry 4-byte rather than 2-byte. Same field, same attribute, you're using a different length descriptor going on there. We've actually got further than that. We've now got 2 independent implementations that have been published, or at least, yes, there's a draft out describing their interoperability, one from Juniper and one from Redstone. So we're now on track in the IETF to actually pass this draft forward, finally, as a proposed standard. So what's the issues around the transition here? I must admit, I'm impressed when I read the draft. It really is quite a masterful piece of transition work, and my hat's off to, particularly to Enki Chen, I think is the lead author there. It's a great piece of work. If you're currently in an AS that's only 2-byte, and all of you are, you don't need to do anything at all. You don't need to upgrade your BGP implementation now or later. You can sit on it. However, if you get handed a 4-byte number where the top 2 bytes aren't zeros, in other words, a number that's greater than 65,536, you will need to run a new version of BGP. So obviously, with a new version of BGP floating around and an old version of BGP floating around, in this industry, we've long since passed the idea of doing a snap upgrade overnight, putting it into production routers and seeing how it will go. If any of you still do that these days, you know, I'm amazed. These days, it's exhaustive field testing, exhaustive transition testing. There's a whole bunch of infrastructure and testing that needs to start up. So at some point, yes, we've got to start doing field testing. At some point, we actually need to start up an AS number registry with all the rest of the larger numbers in it. We'll need the RIRs to start kicking in doing 4-byte AS number allocations. And we're going to have to do a staged deployment of these larger numbers and ultimately phase out the allocation and assignments of the 2-byte AS numbers from the registries. There's a reasonable amount of work. 2 months? 2 years? My guess is 2 years to 4 years. So if we're really looking at 2010, and I think the time is 2005, time is running out. We actually need to start working on some of this. So what I'd like to do very quickly in the last part of this talk is simply run through the aspects of this transition to illustrate how it is intended to work, and I suppose for you folk to gain some appreciation of what's going on there. This 4-byte AS plan in BGP, the objective is to change as little as possible. And certainly the objective is that if you wish to continue running your current version of BGP in a 2-byte AS domain, you should be able to do so indefinitely. What do I need to preserve? Why do we have AS path vectors in BGP? And there are 2 reasons. The first reason is loop detection. BGP explicitly avoids the traditional distance vector count to infinity by explicitly including an enumeration of all the ASs through which that update has already travelled. So if you see yourself, you know it's a loop. You don't have to constantly go up to some RIP metric of 16 or 32 or whatever it was. I've forgotten, thank God. It's in there already. So the AS path vector is all about saying, if I see myself, it's a loop, discard the update. That's the first reason why you have the explicit enumeration in the path. The second reason is the default best path selection process. All other things being equal, and in the absence of any specific policy, if you get two different advertisements for the same prefix, pick the one with the shorter AS path. So when you look at this transition, what you're trying to do is to preserve precisely those two attributes, loop detection and path length metric. And what you're trying to avoid, because it really is out of the question, is a flag day. So the world in which we're going to see 4-byte AS is going to be a world where 4-byte ASs are going to pop up at random places in effectively an unplanned transition. The 2-byte ones will continue to work indefinitely. So how do we do this? The neat way of thinking about it is in terms of boundaries. So when an AS with a large 4-byte field has a peering session with an AS with a 2-byte field, what's going on across that transition, across that new to old boundary? And what the draft does, the approach does, is to define this in two terms. One is, I'm new, I'm speaking 4-byte ASs, you're not. What do I hand across to you in the update messages that preserves all the information required to do path selection and loop detection? And similarly, old to new, what do I need to pass over, how do I map it? The technique proposed is actually two techniques in one, translation and tunnelling. The 4-byte field has, if you will, more information, and when it enters the 2-byte realm, it throws all of the 4-byte AS path into an attribute and pushes it through the 2-byte field as a bit block. The 2-byte field doesn't need to interpret it, doesn't need to know what's in that attribute, the original extended 4-byte AS path. It just tunnels all the way through the 2-byte domain. And you also, and at the same time, you translate. So you take the 4-byte AS numbers and create 2-byte equivalents of them, so that you can preserve the AS path length. So we'll see the details of this, but the basic technique is translation and tunnelling simultaneously. So here's a few transition cases, and this is the first of them, relatively simple. AS1 talks to AS2, talks to AS1:10, that's a big number, 1 is in the high field, who talks to AS1:20. And the update's flowing from left to right, so the AS path becomes 1 and then 2,1, and then it reaches the transition. When the new BGP speaker hears that path 2,1 in 2-byte format, it simply pads it out to 4, so that the AS becomes 0:2 and 0:1, and just continues through the 4-byte realm unaltered. So, of course, as an obvious corollary, you already have a 4-byte AS number, each and every one of you. Just add 16 zeros to the front, because that's exactly the same number in the 4-byte field. Next step, a little bit harder. I'm in a 2-byte world and I'm going back in, sorry, I'm in a 4-byte world and going back into a 2-byte world. Now I've got to do something clever. Why? Because I can't preserve those precise AS numbers in the 2-byte world. They're too long. So here's an AS path that starts at 1:10 and then goes to a new AS, or new BGP, that's actually using an old number, 0:3. Then I go to 1:20, and now here's the transition. Two things happen. I take the AS path, and wherever there are leading zeros, I strip them out. So in this case, 0:3 becomes 3. That's easy. But what about 1:20 and 1:10? I can't map them back to 20 and 10 because they're not the same numbers. So the only thing you can possibly do is whack in a very special AS number, a 2-byte value, called the transition AS value. So you construct a dummy AS path, 2, 3, 4, 5, 6, 3, 2, 3, 4, 5, 6. Does AS1 have a problem with that? No. Because AS1 is not looking for a loop between two other ASs. When it receives the update, it's only looking for AS1 itself. So that path, even though 2, 3, 4, 5, 6 might theoretically have a problem with it, is no problem for AS1 or AS2. It's just a normal path. And its length is still 3. And that's okay, because there are no 4-byte ASs in a 2-byte world. So there's no loops to detect. So that dummy path actually works. The 2-byte world works just fine. But somehow I need to preserve that 4-byte field. Why? Because further down the update chain might be another bunch of 4-byte ASs, and there might even be a loop. So the trick is you take the 4-byte AS path and just lump it down into an attribute of the update, preserving it precisely. So the new AS path attribute, which is that bit at the bottom, is actually just tunneled through the 2-byte world unchanged. Those 3 values are simply passed through the 2-byte world. What about at the other end, when I'm coming out of the 2-byte world into the 4-byte world? Now there's a subtle variation. If I see this attribute, this update, this new AS path update, I substitute it back in the trailing part of the AS. So now if you see the update in blue, 1, 2, 3, 4, 5, 6, 3, 2, 3, 4, 5, 6, and then 2, 1, so on. And now I go back into a new transition. The first thing I do is pad everything out with zeros, so I get a 4-byte field. And then I count the number of 4-byte ASs in the new AS path that I received and substitute back in. What I get back is precisely the 4-byte AS path as if the 2-byte world was already 4-byte. The translation works backwards very cleanly. So now what I've got is a combination of tunneling and translation that effectively makes sure that the 2-byte fields stay in the 2-byte world stays the same, the 4-byte world is doing all the work. Implications. I said before that the existing BGP implementations you're all doing basically can remain unchanged. That's not exactly the case. A lot of you use communities to try and send signals to remote autonomous systems. Yep. If you want to send me a signal and I'm a 4-byte AS, you can't do so unless you support the extended community attributes. So apart from that, 2-byte stuff remains the same. And of course, you've got to pass through this new AS path as just simply a bit block. Just funnel it through, as you do with any other transitive opaque community. So nothing changes. You can run the new code if you want, you don't have to. If you get a 4-byte AS, you have to run the new code. There is no choice. So, if you want to do community signaling in this mixed world, you'll need to support extended communities, and you'll need to do so relatively quickly, I believe. You can't move things on the change. The whole issue about new to old transitions starts at the opened call. So if you and I were running things and I try and dynamically change myself from being old to new or new to old, it won't happen. So I can't move things on the chain, on the fly. What if I'm at an exchange point? Can I represent myself as new to some and old to others? Theoretically, yes, you could. There's nothing in this spec that stops you doing so. But the headache in terms of writing the code internally in the router might prove more than many vendors are willing to actually do. We'll see. So in theory, you can run new and old simultaneously. In practice, it's probably better not to. The other thing is, will you always see a new AS path? No. You will only see a new AS path when a 4-byte went through a 2-byte world. When you're just going from a stub 2-byte to a 4-byte, you won't see anything at all. You'll simply zero pad the AS numbers as they come through. So that, again, relatively simple. There's a whole lot more details here that you might be interested in following up on. All of the maths behind that projection of the 14th of October 2010 is sitting there on that top URL, and if you're dead set keen on doing least squares, linear regression techniques and so on, then please have a look through it and figure out your own technique and come back to me with comments. I'd be interested to hear any. And an extended version of what I've just talked about today, including these transition issues, is on the associated URL there with the paper. Thank you. Any questions?
Hi.
Hi.
Nice introduction to the, a tutorial on the extent 4-byte AS numbers. But what would you do differently if the growth is not exponential? Would you, start right away, or would you delay? Because I think I heard this before, that, I don't know, probably in the middle of the boom, the AS number growth was, we were told that it was growing exponentially, and we were supposed to run out of them, I believe actually last year, and we haven't run out of them. And then quite a few people looked at this data, and I think you compared linear and exponential, and there are other possibilities. For example, 2-degree polynomial seems to have fit that curve much better than exponential. And particularly if to declare something exponential, you have to do a couple of tests. Like, for example, you have to look at the derivative of the curve, or you have to look at the area underneath the curve, and none of those seems to be exponential. So if we had more time, would you still deploy this right away, or is there better alternatives? What would you do differently, basically?
If you have a look at that report, you'll see a whole bunch of analyses, including order 2 polynomials. I have done a reasonable amount of work in that space. I'm still of the view, but predicting the future, you can use any technique you like. I'm still of the view that I think it is exponentially inclined. Not strongly so, but inclined that way. Would we still do it? We've now become a very large, very slow, very conservative industry. It takes us a lot of time to do anything, and particularly something as fundamental as the routing system. Never underestimate, the amount of time it's going to take for an industry now of our size and our weight, of our ponderousness, to do this transition. What's the cost of doing it early? Very little. What's the cost of doing it late? Oh my God. So all I'm advocating here is, considering how slow we move these days, it would be reasonable to start moving on this now, to give us some time to do it without an air of panic and desperation.
I think I agree with you on that, because whether it is 2010 or 2020, it's not really that much time, and just to clear out all the bugs that might have been introduced, it's better to start earlier than later.
Precisely.
But I just want to point out that I think the growth may not actually be exponential. It might be, instead of 2010 and 2024, it might have been 2018 or something, which I think still the time to start working on is probably soon than later.
Or we could all do multi-homing in BGP with our own ASs tomorrow, and it could be earlier. Who knows?
Yeah, the trends can change, obviously.
Randy Bush, IIJ. Seems to me that whether it's October the 14th or the 15th, the year is not that close. And what we're doing, especially if we're worried about bugs, is we have before us a proposal to introduce complexity and open up more bugs and more possibility for complexity, confusion, and configuration messes that will go on well past any conversion date. On the excuse that we don't believe that in 5 years we can have code from the vendors that just supports 4 bits and deploy it. I don't buy it.
Thank you.
I don't think a response was actually required to that. This is Dan Golding. A couple quick questions. First, in regard to your projections, will we be seeing an article from Cisco in the next few days telling us that we'll actually run out of AS numbers, say, in mid-December? Do you see that coming up? Do you feel that your projections are probably agreed to by most folks, or as with IPv6, is there a lot of contention?
Let me go back to this graph, which is actually the critical graph in the forecast. What I absolutely appreciate in this, and I can't see in actually the V4 or V6 graphs, is the phenomenal uniformity of the day-to-day patterns. I actually think that if you wanted a Wall Street business indicator, the AS count in the advertised routing table is one of the more steady indicators of the true business trend, because that is a remarkably uniform curve. And that's the raw data. That's just snapshotting the system every 2 hours. So is there a potential for massive short-term disruption? There hasn't been any in the last 9 years. The curves have actually just plotted, I suppose, two patterns. One, the emergence of a boom, and then the post-boom recovery, which is just business as usual. So in answer to your question, no, I don't see anyone saying, oh my God, the end of the world is nigh in about 3 months' time. Not under these figures. Realistically, AS numbers have a particular usage, and we just simply seem to consume them as business as normal at a rate that is phenomenally steady. So
the reason I ask that is because there's been some recent discussion on the NANOG list concerning IPv6 and multi-homing, and one of the basis of those discussions from some folks is this fear that people will be multi-homing their refrigerators and that their global routing table will explode and there'll be cats and dogs living together, disaster biblical proportion. I mean, do you feel from looking at this that isn't precisely the case?
The trailing 50% of any market moves much slower than the leading 1%. And the short-term perturbations inside that kind of debate are relatively minor. The long-term trends are all about mass market, all about large business scale areas. And in that case, the transitions are slow. So I'm pretty confident that this current post-boom business cycle has that kind of growth associated with AS numbers. And to change that, you've actually got to change some of the business drivers and some of the business models, and even that will take time to appear. So I don't see this as being a sort of a short-term interruptible thing.
Pete Kirkenberg with Utah Education Network. Can you go back to the second slide? So I'm not quite sure how to read this, but does that look like roughly a third of the allocated AS numbers are not in use?
Yep.
So did you look at what would be the impact of recovering unused AS numbers on the deadline?
Yes, I have. And it will buy you a few years. Don't forget at that point, I'm going the wrong way, don't forget at that point, the exponential growth model which I've been using is accelerating steeply. So you'll buy back a couple of years. In fact, I think it's about 4.5. Is it worth it? What are you trying to actually, if you will, fend off? There is no cost to the existing deployed folk. Under the transition plan here, you just keep on running the BGP you've always been running. Will we get new BGP code to support 4-byte ASs inside of 4 years? Well, according to Randy, you'll get it earlier, easily, as long as the industry cries out clearly enough. So I don't really feel that this is a big problem here. It's simply a case of moving forward deliberately and steadily and saying, let's start opening up a registry, let's start doing some work in doing the early trials of deployment and understanding what needs to happen. Okay, thank you.